First, I am going to create this table called part INV. It has 5 columns: part number, division, quantity on hand, price, and date of shipment. These 5 columns have all these values. So the way we create a table is to use SQL, and I have given, I'll show it to you now. Here is the code to create the table. Create table part INV. The first column is part number, and the data type for the first column is char3. The second column is division, and the data type for that is varchar2 25. 25 refers to the width of the column, and so on. And you will note the number, quantity on hand number is defined, the width is defined as 5, which means it has got 5 integer digits in it, or up to a maximum of 5 integer digits. And price is a total of 10 spaces with 2 decimal points. And when we define date of shipment, we simply say it's of the type date, and no width can be specified for a date field. All dates look alike, and the width is predefined, and we don't have to specify it. We should not specify it. And the primary key for this table is part number and division. It's a composite primary key. So the primary key consists of 2 columns. I'm going to define the table, then do certain modifications, add rows into a table. So the next step is to go to your SQL environment. I have already logged into my SQL environment, and you can see my SQL prompt here. So I'm going to click here and type in the code, and I get the message the name is already used by an existing object. So if someone else has created the part INV table, you cannot create it again. So what we do, if a class has 20 participants, just to make it easier for administrative Oracle administration purposes, each one of us is going to create table with your last name prefix underscore and then the part INV table. So it's not part INV table actually, but your last name underscore part INV table. And you have to, even when you insert rows, you have to make sure that you are inserting rows into your table. For now, I'm just going to delete this table. The way to delete the table and all its content is a drop table, part INV. It will drop the table, so the table has been dropped. As you can tell, the create table and drop table are DDL statements, data definition language statements, meaning this is the part of SQL that we use to create a table and so on. When we drop the table, we are not only dropping the table, we are also dropping the contents, the rows in the table. We are also deleting the rows and dropping the structure. So when we do a create table statement, you have to remember we are simply creating the structure of the table. Later on, we have to insert rows into the table. Now, I am going to create it. So if the table name doesn't already exist, you will be able to create the table, and you will see table created. Okay. So at this point, we have created the table, and I go back here and alter table part INV. All that I'm doing here is the quantity on hand is defined as number 5. I'm just changing it to number 6. So that's the command to change it to number 6, and that is also a DDL command. Even though you are modifying the column width, that is still a DDL command because you are simply changing the structure of the table. Again, I go back here, go to my SQL environment, click here. So alter table part INV. So the table is altered. So I have created the table, made a modification to the table. Again, I go back to my code. This is the code to insert rows into the table, and you can see insert into part INV, that's the name of the table. If you are inserting to your table, of course you have to use your last name underscore for this class purposes. Insert into part INV values, and the first column is part number, division, and this is quantity on hand, price, and that's date of shipment. As you can see, the number values do not have apostrophe around it. The date as well as the part number and division has single quotes around it. When you are copying and pasting like this, you have to make sure, I will come to that in a second. So all these rows are created. Sometimes when you copy from a different environment, do you see how the single quotes are in SQL Plus? Sometimes it comes in as left quote and a right quote if you are copying it from a PDF file, and if you have created it in Microsoft Word and saved it as a PDF file, there is a chance that it might be saved as a left quote and a right quote rather than an apostrophe, in which case you will get an error. So to avoid such errors, what you can do is, instead of pasting it directly into the SQL screen, you can paste it into the notepad here, make whatever changes you have to, and then copy it here. I'm simply going to commit. Commit means save these rows. So the next time when you come, the rows will be there. When a database object is created, like when you are creating a table, it is saved permanently until you drop it, if you decide that you don't need it anymore. But when you are inserting rows, it is better to use commit. Okay. The SQL window is set up in such a way when you close the window, it should automatically commit. But if your SQL Plus crashes for some reason, or if you don't gracefully exit, your rows may not be saved when you come back. Later, your rows may not be there, so it's always better to type in commit. Okay. I'm going to illustrate some SQL command. Select star from, when I hit enter, you see number 2 here. It's simply telling you the line number. That's not part of the SQL statement. So this is the proper way, or I shouldn't say proper way. This is the recommended way to type in a SQL statement. As you can see, I'm using uppercase for all the Oracle words and lowercase for the user-defined words, such as the table name part INV is my name, the name I came up with, so I'm putting it in lowercase. And this convention that we are using, uppercase for Oracle words and lowercase for user-defined words, is to improve the readability of SQL statements. SQL doesn't care whether it's uppercase or lowercase, it just executes the command. And SQL statements are terminated by a semicolon. Some environments, meaning interface to SQL, will automatically insert a semicolon, and it may forgive you if you do not put a semicolon, but the SQL standard is you need to include a semicolon, which indicates the termination of the SQL statement. So in this case, select star means select every column from the table part INV, and you see a listing of all the columns and the values that you inserted. Okay. If you just want to see the table, you can say describe part INV. It will give you the structure of the table. If you want to see the contents, you have to see select star. And the select has some important variations. If you don't want every column to be listed, you can say part number, comma, division from part INV. Okay. You can see in the heading, only PAR is listed. The column is actually known, when we created the table, we called it part number, but only PAR appears here. That's because the column was defined as 3 spaces wide, so it truncates the name of the column and gives you just the 3 letters, the first 3 letters, which is the width for that column. So this kind of select statement tells you that you can restrict the columns that are displayed from the table by just including specific column names that you want displayed. Another thing I want to illustrate to you is when you do select part number, division, you can also use expressions, price times quant on hand. Those are the names of the columns. Here I want the part number column and the division column, and I'm saying price times quant on hand, which is I can give it a name as amount, okay, from part I and B. This select statement, when we execute, will give a result. It will give you the part number column, it will give you the division column, and the column heading will be amount, and it will give you the computed result of price times quantity on hand. I'm doing this to illustrate to you that when you use a select statement, you just are not restricted to using just column names, but you can also use expressions. Price times quantity on hand is an expression, is a mathematical expression. It could be any expression involving numeric data types, and this is called a column alias. So if I don't put it, the command will still work, but the column heading will be price times quant on hand. But I'm just for again improving the readability, I'm calling this as amount. I hit enter, and you can see the amount is this. And also there are various ways of formatting, with the 2 decimals and all that. I'm not going to get into that right now. The next thing I want to illustrate to you today is the creation of views. The table that we created using the create table command is known as a base relation. A base relation is an object in a database, and it has permanent existence. Permanent in the sense until you drop it, it is still there. Okay, so that's a base relation. There is another relation. I'm using the word relation as a synonym for table. You can interchange these 2 words: base relation, base table. So we have the base table part I and B, which we call it a base table because we used a create table statement to create this table. So that's the underlying table which contains all these columns and all these values. As opposed to a base relation, you can have also a virtual relation. A virtual relation is known as a view. Okay. I will first create a view. It's not difficult to create a view. I am just saying create view as select part number, division, quant on hand, date of shipment from part I and B. So this is my SQL select statement. I'm creating the view. I made a mistake. I need to correct that. That gives me an opportunity to show you how to correct your mistakes also. I have to give a name for the view. Okay, I simply said create view, but I have to give a name for the view. Let me do that. Now there is a mistake because I did not give a name. I'm using the up arrow key. See the last line that I typed in from part I and B, the previous number I'm typed in. So create view Now I'm going to give a name for the view. I'm going to call it v underscore part inv to make you easily see that v part inv is a virtual relation or a view. You are not obligated to use v underscore. I'm just doing it because it's easily identifiable when you do it this way. Okay. So the other columns, I'm using again the down arrow, up arrow key. Okay. Create view. I have to say as, I will just retype it. Actually, I'm going to get rid of this. I'm going to start from the beginning. Create view v underscore part inv as select part number, comma division, comma quant on hand, comma date of shipment. If you don't want to type in, you can use the up arrow key or the down arrow key depending on where you are to bring back the statement that you already typed in. From part inv. So here, if you look at it, I have a select statement. The first thing we note is to create a view, you need a select statement. The select statement select whatever columns you need from another table. And right now it's selecting all the columns from a single table. Later on we are going to see that this select statement can draw columns from multiple tables also. You are not restricted to doing just one table. So basically, what we want to infer from this is you need a select statement that performs some relational operation from some set of tables, and the result is stored as a view. Here in this simple case, we are just selecting all columns except the column price and storing it as a view. So let's go ahead and hit enter. It says view created. Now what we have is a table called part inv and a view called v part inv. Let us see what is in the view. Select star from v part inv. That's the view. Again, when you create a view and you populate the view like we have done, you don't have to explicitly populate. We'll come to that in a second. When you say select star from v part inv, you can see that we are using the view as if it were a table, a base relation. So for all practical purposes, a view behaves just like a table. Okay, that's the first thing you need to understand about a view. So now I say select star from v part inv. I have all the columns. I say select star from part inv. This is the table, and the only difference is the table has the column price, the view doesn't have the column price. So that is the first use of a view. If you have a view, you can protect certain columns. Suppose we have a new user and we want to give the user access to the table part inv, but we would rather not give access to the price column to this particular user. Then you can create a view like we did, which excludes the price column and give access to the user only to the view, not to the underlying table. So a view is kind of a tool, a method to implement security. If you want certain users not to see certain columns, just hide those, create a view and give access to the view. The second thing that you need to clearly understand about view is that the base relation part I and V, as in this case, has a physical existence. The view doesn't have a physical existence. The view simply pulls data from the underlying base relation. So although we are using a select statement and it looks exactly like that, a view has only a virtual existence. The underlying base relation has a physical existence. That's what we need to understand. If we add another row to the part I and V table, the view will get automatically updated with the new row that you are inserting. Okay, so let's go ahead and try that. Insert into part I and V. This is how you insert values. If you are inserting into your table, then you have to use your last name underscore part I and V. The first column is part number. I'm just going to make up a different part number so that I can easily identify the one that I have inserted, part number. Division, I can give any division name. I'm going to say Jurassic. Part number, division. Quantity on hand, I'm going to say 99. Price is 99.98. I'm coming up with all these weird values so that I can easily see in the newly inserted table. And date of shipment, I'm going to say 12th January 2019. Okay, I'm going to hit enter. It says one row created, correct? So again, the row has been inserted. Now I'm going to do select star from part I and V, 11 rows, select star from V part I and V. You can see the newly inserted row as the last row. 999 Jurassic is what we inserted, and I have to make sure it's underscore not dash from V part I and V. So the view is automatically updated. You see the V part I and V also has the added row, and now the only difference is the price column is again absent from the view. So that is the fundamental notion of a view and how it works. You may have one question, you inserted into the base relation and it is updated into the view. Can you do it the other way? Can you insert it into your view and will it show up in the base relation? The answer is it depends. In certain cases, the view will be updated. In other cases, the update will fail. That's because under certain circumstances, the view becomes not updatable. I will give you one example. Suppose you have created a view that omits certain columns from the original table, and one of the omitted columns happens to be a required column in the underlying table. Okay, we are going to talk about required columns, means the value cannot be null. If it's a required column in the base relation, and if the view does not contain that column, then the view, you will not be allowed to insert into your views. Again, there are certain restrictions on if the view contains, in the illustration we just did, we just used one table. The view can come from multiple tables, in which case the view may become theoretically not updatable. Okay. So those are the things I wanted to illustrate in this lecture. And before I quit, I'm going to illustrate one more point. See, last time when you insert, you said commit to save the rows. If I say roll back, it will say roll back complete. And rollback commit or SQL statement, so you need a semicolon. I'm going to say select star from path INV. You can see the newly inserted rows is gone. So rollback is, hey, I don't want to save the whatever changes I made to the table. But you can also note it did not get rid of the rows that are previously inserted because you said commit. Okay. So when you say rollback, the rollback applies to only those rows since the previous commit or from the beginning of the session. So remember that. If you did something that you didn't want done to the table, you can always say rollback. You don't have to drop the table and recreate it unless you want to for other reasons. So when you say commit, all the DML statements are committed. Okay. So rollback and commit either applies from the session start or from the previous rollback and commit. Again, I'm just explaining this in a very fundamental way. There are all kinds of nuances to commits and rollbacks, and we'll talk about that at a later time. Thank you very much.